How can we learn more about the nature around us to make us build better things in our own lives? That's what we're going to talk about today. Hi, this is Jill from the North Woods talking about nature right outside our front door. There is a term that maybe you never heard of called biomimicry. And that is when we look around nature things, birds, spiders, anything around us, and we try to learn how it did it so that we can run and make things better in the human experience. People have been doing this for a really long time, and nature has been perfected through its creation to make some of the best things on the planet. Think about how birds cut through the air, or an owl flies silently in the wind, or a spider web holds up strong even in the course of rain. These inventions that are done by nature right outside our door is sometimes even better than what the human imagination can be. And paying attention to it can help us build better things. This biomimicry, the art and science of learning from nature to solve human problems, is more than just copying what we see. It's about understanding the deep engineering that lies behind it. There's a woman named Janine Benyus, I think that's how you say her name, who helped define this. She said that nature is a model, a mentor, and a measure, and that when we learn from nature, it will help us make better things. And I think we have done this instinctively for a really long time. I think when we first started with human flight, it was very carefully explored. Wait, how are birds doing this, and why can't we do this? I even saw a place that was in some of the earliest places society has ever existed, some of the hottest places that societies have ever existed, and they create these natural dome-like material buildings that are cool on the inside, naturally cool on the inside. And when you read about them and how they figured it out, they learned it from termites. They looked at the termite structure of, those termites that make the big domey things, and they learned how to make their own housing areas cooler so that they could get refuge from the hot burning sun without, obviously thousands of years before electricity. And so we now have the ability to do it even better. We don't just have to look at nature around us. We can try to figure out what is really going on with what nature is creating. How is nature doing this? How are they structuring this? I remember hearing about how they were using spider webs to understand how to make bulletproof the vest better. And even more so than just like the bulletproof vest, how can we use energy differently? How can we build structures better? Adhesion, how can we get things to stick to each other better? How can we fly better? Or how can we filter water or air even better? These transformative ideas is sometimes like us just looking at how a burr is structured, the thing that just sticks to our shirt from a plant we can't get off. I can't get off. Bird beaks or bird wings, or how a whale fin glides through water. We have been doing this, like I said, for a really long time, for as long as it's been. But even in modern times, the kingfisher was looked at. The kingfisher is a really amazing bird. He likes to hang out on a branch. I have them right around here too. I just love those little guys. And they will then dive into the water in almost like this bullet-like formation, pierce the water, grab what it is they're grabbing very quickly, and then come right up and then fly away with it. The Japanese were looking at how the kingfishers were doing this through trying to make these bullet trains glide a little bit better. I guess when bullet trains first came out, if you have things that are going very quickly, you have to think about the air, you have to think about the energy, you have to think about all sorts of things. But when it was going through tunnels, it would make this very thunderous, booming exit noise. And so the redesign teams looked to the kingfisher birds. How can the birds go right through that water and pierce it with barely making splash? And then they reshaped the nose of the train to match the beak profile, and it used 15% less energy, it increased 10% by speed, and the noise was reduced. It's one of the most famous examples of human doing observations of animals and using biomimicry to succeed. It's a way we can use engineering. We looked at whale fins to understand how we could make air turbines more efficient, turbine blades, because the whales have a little bumpy edge called tubercles. And it turns out these bumps help them maneuver through the water with increased efficiency. When the engineers mimicked those edges, the blade drag dropped by 33%, and then the lift was increased by 8%. The U.S. Naval Academy confirmed the physics of whale-powered design for other commercial uses, making energy cleaner, quieter, but also making our vessels go through the water better. The most famous thing that I heard a long time ago was that there's a Swiss engineer who's walking his dog, and he noticed how these burrs, we talked about how seeds move around us. But if you have something like thistle or burdock, it will get on your clothes. And I don't know about you if you've ever done this, like mowed the lawn and then brushed up against something too closely. You're spending the whole night picking all that off because it is really grabbed in with hooked barbs into your clothes. When he looked at it under a microscope, he invented Velcro. It was that idea that this moment in nature gave him an idea of how we can make a connector for astronaut suits, for sneakers, I use them in sewing projects. My watch band is connected with that too, all because he went and looked at a burr under a microscope. We used geckos. Geckos can climb walls, right? And they have little tiny micro hairs on their toes that create like a molecular level stickiness. So engineers looked at this mechanism to create residue-free adhesives that we now use in robotics, prosthetics, surgical applications, because now we understand a little bit better how to make a better adhesive. Shark skins and other antibacterial surfaces are something that we started looking at that. We've been using antibiotics way too much, and we know it. But what can we do to protect ourselves against bacteria without using so many antibiotics? The microtexture of shark skin naturally repels bacteria and algae. And so that inspired Sharklet Technology, who makes medical film, catheters. It reduces the growth of bacteria up to 97%. And it is safe for human use. And so they've been improving healthcare by looking at how sharks do it naturally. Like I mentioned before, that in Zimbabwe now in more modern times, there is something that is called the Eastgate Center, which has modeled its ventilation system after the termite mounds, much like the ancient people, and it uses 10% of the energy of compatible structures to keep it cool. So having inspired architecture can help us to understand how can we make living places more temperate, cooler, easier to use, and maybe offer more passive cooling. I know of some passive heating systems, but now we have passive cooling too. Think about spider webs, and spider webs inspired this Ornolux bird-safe glass. So we know if you have a large bay window or a patio window like I have in my house, birds can't see it very well. And so they will hit the glass and either injure themselves greatly or potentially die in that collision. And so this company came up with a glass using the pattern of a spider web to mimic that, and the birds can see it. They don't fly into it, and so it saves energy because it's also very E rating so that you don't get a lot of heat light coming in the summertime, and it helps the birds survive. We have seen situations where that hasn't happened very well, but using the way that spider webs are created can help us save birds and save ourselves a little bit of energy too. Think about too, like nature-inspired water and energy solutions. There is something called an aquaporin membrane, and water cells filter through this channel called aquaporins, and it uses this selective filtration system the engineers mimicked this to build the next generation of water purifier membranes. It's more efficient, more durable, and they even are able to use this type of silica that was based on something they found in nature to strengthen the coating on it, making it for longer time use. So it can make water safer and more cheaper for us to drink. A lot of people are hikers. They go out and they drink water from rivers and lakes. Some people, that's the only water they have. And so having these kinds of membranes can help you have safe water that lasts a really long time too. In Namibian desert, there's a beetle, and it's called the Namib beetle, and it collects basically fog textures on its back. It channels these droplets of water that come from fog, and it channels it into their mouths. And so now we're having some sort of a design that inspires this water harvesting material so that we can go to very dry places that don't naturally have water and get water just from the air around it. So mimicry is changing all sorts of things. Now, think about, like I said, I mentioned before, architecture. There was something that was called the Eden Project, and it was using this lightweight ETFE panels that was modeled after plant cuticles, this strong, self-cleaning sort of natural insulation. And so they were using this plant-like structure to build buildings that would be lighter weight and better panels to be used for the sides of buildings. In Singapore, they created something called Gardens by the Bay super trees. This mimicked the way real trees collect rain, provide shade, and generate energy through embedded in solar cells into these plants. And so it shows that really urban designs can coexist with the principles of living systems, that we don't have to fight nature in our cities all the time. Instead, it would be nice if we sort of incorporated it in and used it. But there are times when biomimicry hasn't worked out for us, and so it's not always successful. There are some rather notable events of when it happened. There were some biomimicry ventilation systems that were based on some termite logic, and it ended up causing humidity, mold, and unstable temperatures inside the building. And the primary reason for that is they misunderstood the balance between what the termites were doing. So if we don't really fully understand what the animal is doing and how they're producing what they're trying to produce, it can actually come up with some rather bad results. There have been situations too, and maybe you've seen these, where we're trying to build robots now. And some of these robots are modeled after animal movements because animals are very good at adapting to conditions, terrain, and maybe a little bit better than we can. And so we've been trying to figure out, like, how can they do it? And you've seen some really bad robots out there who are, built after dogs or built after human beings. They can barely walk. They trip over the smallest item, and it hasn't worked out as well for us. We're still learning how to fine-tune these systems so that we can copy them and use them in more robotic ways. There were some food design problems too. Plant-based or lab-grown meats have been tried in the past. Big misfires. They don't feel or taste like the real thing. They had really terrible consistency. But here was the interesting thing. I eventually tried one of I think it was Impossible Meats. It actually does taste pretty close to meat. It was pretty close to it. But the weird thing about it is it wasn't less, it wasn't more healthy for us. It still had the same amount of saturated fats as meat. And the process of making it was worse than actually just having meat. It's a new thing for us. You always start bad and you get better at it over time. But there have been some places where it just has not worked out very well for us. But, like I said, we have failures and then we build on these failures. And most of these failures happen because we don't understand the entire system. We miss a deeper biological principle. There's some sort of a miscommunication between the designers and the scientists. Or maybe those things don't scale. Sometimes what makes a little beetle work properly doesn't work for making a robot work properly. And so we have to remember that it's not wasted effort to look at animals and try to understand how nature works. A lot of times failure is part of the experiment. So We'll learn more and we will do more with it. I think the interesting thing is that nature really doesn't waste much. It optimizes, it adapts, and if we can learn more and more about the natural world around us, it can help us build better cities. It can help us build smarter energy, smarter transportation, better buildings, maybe, like I said, better glue and better Velcro. And so it sounds awfully poetic to say that these nature things can lead us to real answers when it comes to our own lives. They really can. So I think sometimes when you look at a spider silk, or you see a fish gliding in the water or a bird up in the air, maybe think, what exactly is it doing that we could be doing a little bit better? It invites us to have a great bit of observation, a moment of learning to build something so that we can make our lives better too. It reminds me, when we start seeing structures built in bee honeycombs, or we start looking at the ways birds build certain kinds of nests, we can learn so much more about how we can build things by doing that. It's one of those really interesting things. I've been seeing it more and more. And so I hope that helps you kind of think a little bit more creatively. Sometimes, I guess, if you see nature outside, think, how is this happening? Why is it happening? Why does this work so well? Is there something that you could notice? That's what being a backyard or an outdoor naturalist is about. Noticing something that maybe someone else missed. And maybe then you can invent the next super glue. All right, everyone, thanks so much. I appreciate you watching, listening, however you're getting this. This is on podcast and it's on YouTube. Please leave comments if you're watching this on a video channel. Please email me at Jill@startwithsmallsteps if you are listening to this or want to say something private to me. I appreciate you being out there. Thanks so much and have a great day.